In this video, I am going to discuss Venn diagrams and probability rules. First, what is a Venn diagram? A Venn diagram is a picture that represents the outcomes of an experiment. It generally consists of a rectangle that represents the sample space together with circles or ovals. The circles or ovals represent events. This is a Venn diagram for a single event. The rectangle represents the sample space and the circle E represents the event. This is a Venn diagram for two events, E1 and E2. And here you can see there is a common region for both E1 and E2. Then how about for the three events? Yes, this is a Venn diagram for three events, E1, E2 and E3. Before I talk about Venn diagram with more details, let me explain probability rules. First, probability of an event is always between 0 and 1. Minimum probability is 0 and the maximum probability is 1. What is the probability of the sample space? It is always 1. Now let me define complement. The complement of A, that is an event, consists of all elements in the sample space except A. So you see the notation, it is A bar. Now let me give you the complement rule. Probability of A complement equal 1 minus probability of A. How do we use the Venn diagram to show the complement? Yes, again, the complement of A consists of all elements in the sample space except A. That means the area outside of the A but in this rectangle, the sample space. So this is the area of A complement. Now disjoint. If two events A and B are mutually exclusive, or we can say disjoint, then they have no outcomes in common. That means no common region. This is the Venn diagram for the disjoint events. Again, we can explain with more details. They can't occur at the same time. The outcome of the random experiment cannot belong to both A and B. Now let me explain the intersection. The intersection of events A and B, denoted by A intersection B, you see the notation, consists of all outcomes that are in both A and B. So this is the common area of both A and B. That means that is the A intersection B. So what is the area left of the common region but in A? That is only A. And similarly, the area right of the common region and in the B, that is only B. I will explain with more details in a later video. Right. Now let me explain the union. The union of events A and B, you see the notation A union B, consists of all outcomes that are in A or in B or in both A and B. You know, I can explain this way too. The area only A and area only B and area on both A and B. So this is the union. Next problem is, how do we recognize this union, intersection or complement? Yes, I can explain this way. Complement, if you see the word not, so you see the area, the A complement. The intersection, if you see the word and the union, if you see the word O. Yes, so that's the main key to recognize these three events. If two events A and B are mutually exclusive, I explained this before, that means disjoint, then probability of A or B equal probability of A plus probability of B. A or B mean A union B. So what is the A union B mean? That is the all elements in A and all elements in B and the both. But here no common region. Therefore we can write down probability of A or B equal probability of A, that means the A probability and probability of B, and add them together. That is the probability of A union B. Right, let me explain this with more details. What is the A intersection B equals empty mean? That means no common elements, right? Is common region is empty. So that is the disjoint. Okay, that means probability of A intersection B equal 0. Again, the probability of any empty set is 0. Let me explain some examples. If probability of A equal 0.35 and probability of B equal 0.45 and A and B are disjoint, then how do we find the probability of A union B, or we can say A or B? Yes, by the rule we know probability of A union B equal probability of A plus probability of B. You can use this rule if and only if A and B are disjoint. If A and B are disjoint, this is true. Otherwise, it is not true. Right, then we know A and B are disjoint. Therefore, probability of A union B equal 0.8. We add them together. Next example. Which of the following events are disjoint? What do you think? Okay, if they are disjoint, summation must be equal to the probability of A or B, right? Or A union B. Part A. Probability of A 0.3, probability of B 0.25, then the probability of A or B 0.55. Yeah, that is true, right? The probability of A plus probability of B equal 0.55. But check the BCD, they don't equal. As an example, go to the D, probability of A is 0.4, probability of B is 0.4. Then if they are disjoint, the probability of A or B must be 0.8, but here 0.7. In my next video, I am going to explain finite probability models.